Superbrain uIDE tech demo take 2. Okay, so I fixed the driver, I think. It turns out I wasn't initializing the IDE device properly, and so we're just getting garbage back when we tried to look at what was on it. So now we'll reboot the Superbrain. Now this is the boot prompt of my Superbrain, and the reason it offers a hard disk boot is because it used to have a hard drive connected to it, and it's still got the hard drive ROM. This ROM, or this hard drive boot, isn't usable with the uIDE. Anyway, so we have to boot from floppy, and there's the CompuStar Model 30 boot. The only reason I use this boot disk is because it's got additional features to the normal Superbrain boot disk, like keyboard type ahead and auto repeating keys. But otherwise it's a Superbrain boot disk. So if we launch the driver then, like we did before, and again we can see we've got A and B and IDE drives C to P inclusive. So if we go into C, hopefully it's going to work now, and there. So now the reason why it has that slight delay is because C's got an awful lot of files on it, and in order to show me what's in user 0, it's got to scan through all of the all of the user areas. So on drive C, user 0 has just got a few bits and pieces on it, but the other user areas are quite full. So if I do user 1 for example, and then look in there, got a load of stuff. User 2, load of stuff, load more stuff. Now what's actually on this disk is a copy of the N8VEM demo image, which has got a stack of useful CPM tools. So for example, in drive, I think it's drive D, and user 2, is this the right one? No. Okay, user 3. I've just got to try and find it. I can't remember where the stuff is. I think a map would be useful. Anyway, as you can see, there's stacks and stacks of stuff on the IDE drive that we can play with any time we like. Let's get back to C though. Okay, so user 0 C, right. Okay, so we have some utilities here on user 0. Most of these are related to the PCW, so can't really use them. But it would be nice to do a little bit of copying just to demonstrate that you can get stuff from the drive and copy it around, and it will also show one of the limitations of the demonstration. So if I go back to drive B, have a look on there. So B is an ordinary boot disk, and it's got pip on it. Because pip is the peripheral interchange program that CPM users will use to copy files around. And the syntax is a little bit arcane, but I can copy all of B onto drive C, for example. So let's just do, if I'll clear down, no, let's just do C equals star dot star. And you can see it copying stuff onto the disk. Now remember, down here there's a green light, and that's the disk activity light. So it flashes as the IDE drive is being accessed. So we copy all this stuff from the floppy onto C. Now of course the reason it's slow is because we are copying things from a floppy disk. So it's actually the speed of the floppy disk that's making this look a bit sluggish. I think that's enough actually. Let's break into that. I'll try to. Okay, so pip doesn't seem to want to listen to my Control-C, so we'll have to let it finish. It won't take too long. Okay, those last two Control-Cs were what I pressed whilst pip was copying. Right, so one of the side effects of using pip is that the machine, when it's finished, will execute a warm boot, and because it's executed a warm boot, the driver, which has been loaded into the TPA, it's probably still in memory, to be fair, but the problem is that the BIOS jump table, which is patched by the loader program, will have been reset to original vectors. So what this means now, after using pip, if I want to access the hard disks, I can't, because the patches have been removed. So, for example, if I do that, it just says, "Oh, I can't find it," which is a pain in the bum. So what it means then is that we have to reload the driver, which will repatch the BIOS table. So we'll do that now. Okay, so it's reloaded and everything's there. If I click C, it's all present and correct. And those are all the files we copied. Now let's see if we can find an empty disk somewhere on this thing. A, B, C, D, E, F, G, H, I, J, K. Let's have a look at K. K, see if there's anything on there. Yeah, nothing on there. This is a problem with the formatting program. Let's just K star should clean it up. Right, now K. Oops, K. Okay, so now K is clear. So I'll go on to C and I'll do pip K colon equals C. We'll just start at star. So this will copy everything from drive C onto K, and you should be able to see it's a little bit faster than the floppy disk. But again, when pip completes the copy, it will do a warm boot, which will reset the BIOS vector table. Q, come on. So that's why this is a demonstration, really. I could release it, but it's not a permanent solution. As I said in the previous video, you have to move the whole operating system down so that the IDE driver code is living above the BIOS, and that means that warm boots won't affect it. Of course, the ultimate way of doing this, as I mentioned previously, is to write a whole new BIOS that incorporates all of the IDE driver code, and then it doesn't matter. And then finally, you've got to modify the boot ROM so that it pulls the boot tracks from the IDE drive, and then that will be done. Okay, so we cannot, because we were on C and the pip program has done a warm boot, we can't access it anymore, so we have a BDOS error. And the only way to get out of this is to do a hard reset. So you press the 2 red keys like that, and then you're back here. Okay, so launch the driver again, and if I go into K now, I should see all those files that we copied across. There they are. Very nice indeed. Right, okay, so now this driver code, all the driver code here is based on the TRS-80 Model 2 driver I wrote a couple of years ago, and that means it's supported by the tools that were supplied with that driver. So, which I put on the A drive. And one of the ones that's the most interesting is called XMAP. And what it does is says, okay, these drives that are listed here, they all exist inside the driver code in the way of a kind of mapping table. And the idea is that the logical drive name, which is A colon or B colon or J colon or whatever, can be assigned to an actual physical drive. So on the IDE device, the space in there is 128 megabytes. It's actually a little bit less, but anyway. And that is just sort of partitioned up. Now, they're not partitions in the PC sense of the word, they're just chunks of space on the disk. And the IDE driver treats a logical drive as being one of those chunks on the IDE drive. So you can use the mapping table to say, I want this logical disk, for example E, to point to the chunk of space at the very end of the disk. And the mapping program is what you use to do that. It's called XMAP. And I will first, what I'll do first is I'll show you what the driver is currently set up as. So input memory, oops, sorry, -IM, which means read your input from the memory driver, the in-memory driver, and then -P, which says print what it says. So here, so if you look at this, it's completely broken. I forgot to recompile it. Alright, so I'll show you this in the next video.